In the previous video, we got a couple of very important limit statements of trig functions that we were able to get out of the squeeze theorem. And what we want to focus on now is how we actually apply those limit statements to evaluate some limits of other trig functions. So let's take a look at the limit as x approaches 0 of the tangent of x divided by x. Well, if I substitute 0 in, that tangent of 0 is 0, and x obviously would be 0, so I get this indeterminate form. Now then, when it comes to trig limits, if you see tangent just kind of as a general rule, it works in your favor if you will break tangent into sine over cosine. So maybe as a little bit of a sidebar, remember that the tangent of x is equal to the sine of x divided by the cosine of x. Just kind of as a general rule, if you see tangent, breaking it into its sines and cosines can be very helpful. And that's what we're going to do here for this limit we're trying to evaluate. The limit as x approaches 0, if I break tangent into sine over cosine, I can move the cosine down here to the denominator and say that's the sine of x divided by x times the cosine of x. Well, if you look here, I've got the limit statement we just said. Earlier we said the limit as x approaches 0 of sine of x divided by x was 1. I can pull this out, and using my algebraic properties of limits, I can rewrite this. Let's pull it out first and say this is the sine of x over x times 1 over the cosine of x. Well, I now have the limit of this product, which I can break up into the product of the limits and say the limit as x approaches 0 of sine of x divided by x times the limit as x approaches 0 of 1 over the cosine of x. Now then, this right here, this first piece, that's the identity statement that we just verified in the previous video. The limit as x approaches 0 of the sine of x over x is equal to 1. We showed that in the previous video, so we can now use it. If I take a look at this limit, I can evaluate it directly because 1 over the cosine of 0, the cosine of 0 is 1, and so this whole value just happens to be 1. So this particular limit right here is equal to 1. A variation of that particular statement occurs if I look at the limit as x approaches 0 of x over the sine of 3x. This looks very similar to what we just established, except for the fact that the argument inside of sine is 3x, which means I need a 3x right here in order to get that identity statement to work. And so I can get a 3 in front of that x as long as I also multiply the denominator by 3. So algebraically, let's talk about what we want here. I want the 3 to be with x because then I have 3x over sine of 3x, and even though it's got 3x, that is my special limit statement that we got from the last video. So the 3 in the denominator right here, I know that I can take any scalar multiple and move it outside of the limit statement, and so I'm going to go ahead and do that right now and say that this is equal to 1/3 times the limit as x approaches 0 of 3x over the sine of 3x. And you can see now where my 3 over 3 is. Here's this 3 and here's this 3, and that's a very valid algebraic move. Well, this right here is 1. The limit as x approaches 0 of 3x over sine of 3x is equal to 1 times the 1/3 that's out in front of it. And so that limit evaluates to be equal to 1/3. So just a little tweaking gave me where I had the argument inside of sine to go along with my x here. I was able to generate that particular trig limit statement. All right, let's take a look at one last limit here. Let's do the limit as x approaches 0 of the sine of x times 1 minus the cosine of x divided by x squared. Now then, this is where it takes a little bit of intuition to really see what's going to happen. I can already see that sine of x over x is going to be my friend. So I'm going to go ahead and split that off and say the limit as x approaches 0 of the sine of x divided by x, I need to make sure I address what I have left. So I'm going to have 1 minus the cosine of x over x. And I can say the limit of that product is the product of the limits, the limit as x approaches 0 of the sine of x divided by x, times the limit as x approaches 0 of 1 minus the cosine of x divided by x. And these are the statements that we had from the previous video. This value right here we defined as equaling 1. This particular limit statement was the other one that we added to our notes, and we said that it was equal to 0. So this whole limit evaluates to 1 times 0, which of course is 0. So knowing how your sines and cosines interact with each other, and being able to generate those statements that we had in the previous video can be a very helpful tool in evaluating some very special limits involving trig functions.